I think it's time, actually. So I have this thing I like to do where the talk's supposed to start at, in our case, 5:40 p.m. And so what I like to do is start at 5:40 and 59 seconds. That way, it gives that extra 59 seconds for someone still to be on time. And usually that person walks into the door just as I'm saying it, and that's awkward because they walked in at the last minute. Thank you, sir, for being part of my joke. So how's everyone doing today? Your brain's full? Ready to do something fun as opposed to something work-related? Not that our job isn't fun, but they do have to pay us to do it, right? So this is tracking aircraft with, I think it says streams in software-defined radio. I need to update my slides. It says Redis in software-defined radio. I work for Redis. I was trying to make it a little less product-forward. But this is a talk on software-defined radio and just an introduction to that topic. And we're going to build a cool thing where we track real-time aircraft from the skies of London and the channel, hopefully all the way out to the channel. We'll see how that works. We're inside of a concrete box, but I did pick up stuff from the speaker room. We should be able to pick up something. So, my name is Guy Royse. I am a developer advocate at Redis, and well, there's really three things on this slide that matter. There's something that matters to you, there's something that matters to me, and there's something, that matters to my boss. Right. My boss would like you to know that Redis is more than just a cache. Who's used Redis here? A quick show of hands. How many have used it for something other than a cache? Exactly. What did you use it besides caching?
I used it for what it was now.
Was it PubSub? That's usually the answer I get.
PubSub as well.
Yeah.
I was trying something else, not related to cache or PubSub.
Just using it as a database?
I used it to, what was it called now? Sorry, my mind is...
That's okay. I'm going to plow through, so.
Come back to you.
Yeah, we'll circle back around. So, but yeah, yes, sir.
We used it for locking and synchronization.
For locking?
Yeah.
There's a library around that. Redlock, I think, is a popular library for that. So people do use it for lots of things. It tends to be used for very ephemeral things, but what my boss would like you to know is that Redis is more than just a cache, more than just a PubSub. It's got a lot of other capabilities. You can do JSON, you can do search, you can do event streaming. And so if you take anything away from this today about Redis, just know that Redis has event streams, and that'll probably be about all I talk about it. But so that's his objective. And that's what matters to him. Frankly, it matters to me a little bit because I would love for my options to turn into a big pile of money. So please help me out. The thing on this slide deck that matters to me, on this particular slide, is, and I'm not sure it matters to me as much as it used to, but is that GitHub, the Twitter handle there. It's Twitter, currently known as X. I think that's how we say it now. If you're still on Twitter or on X and you want to give me a follow, that would be much appreciated. I measure my value as a human being by how many people follow me on social media. So give me a follow. I promise I don't post anything political. And the thing on here that matters to you the most is that GitHub URL right there, github.com/GuyRoyse. All of my code and samples for all of my projects, slides and everything, are out there on GitHub. And so if you go to github.com/GuyRoyse, you can pull all that down and play with this yourself. I am going to brag here that I do have guy.dev as domain name. Which was a wonderful coup, totally worth having. And if you are a ham radio operator, who here is a ham radio operator or into radio at all? Okay, well, I was going to say that I'm not an expert, I'm learning, but actually I am an expert and you should trust everything I say. So if you're into ham radio, my call sign is Kilo Echo 8 Victor India Yankee. So that's the intro slide, boring stuff over. I want to just sort of set some expectations here for this talk. So rule number one, I'm not an expert. I made a joke that you should trust me totally, but I'm not actually an expert here. Radio is a big topic. Software is a big topic. Redis is a big topic. And I work for Redis, and I've worked there for several years. And if anything on these categories, you could say I'm an expert in Redis, but there's still corners that you don't have. I'm an enthusiastic learner. And so what I do is I go out and I discover new tech, I get excited about it, and then I put together a talk. So that's what I did here. And then I sprinkled in the Redis so that I could do it for work. So I'm not an expert. I may get some small things wrong here. So The other thing is that there are going to be a lot of demos because this is kind of a toy-heavy talk. I've brought some radios. I've got some bunch of fun software I've written. So there's going to be a lot of demos as I show you how all this stuff works, which is really kind of the fun part anyhow, right? So there's going to be a lot of demos. And this talk's it's not as bad as it was when I first created this talk, but it's a little all over the place. And that's because I'm going to talk about a lot of things. I'm going to talk about radio, software-defined radio specifically. I'm going to talk about aircraft and the radio broadcasts they make so that you can find them and the information you get. I don't know a ton about aviation. I'm not an aviation person. But I know the data that comes off of it, and I'll talk about what that means. We're going to talk a little bit about event streaming. If you've done event streaming, then this will be a very basic introduction. If you haven't used event streams, then this will be just a really basic introduction to the idea of an event stream. And we're going to be talking about how I can do all these things interact with. I'm going to build a demo on top of Redis, basically. So, excellent. So the first question, the most important question, is what the heck is a software-defined radio? You probably saw the title and said, software-defined radio. I don't know what that is, but that sounds fun. It is fun. Well, it's a radio that you plug in your computer. I've actually got one here, right here in my hand. I bought this on Amazon for, at the time, I think $25. I think they're a little bit more now. So it's probably 25 quid now. But it's a radio you plug into your computer. One end of this radio has an antenna. It's an SMA antenna port, just like on the back of like a wireless network card. The other end has a USB port. And what it does is it samples the audio spectrum from that antenna, or the radio spectrum from the antenna, and sends the raw data from the air down the USB port, where it can be processed by the computer. And it's got some basic tuners in it, so you can point it at different frequencies. You can adjust how wide you want to sample and how frequently you want to sample. And so you've got an antenna port on one end, you've got a USB port on the other end, and if you're like me and you're bringing this from the United States and you have to go through the TSA security and customs and everything, you need to make sure you label it properly. Another way to think about a software-defined radio is that it's like a regular radio, but with less stuff. So these radios I have here on the screen, just like this radio here that I have in my hand, they have all of that stuff that I just described in the previous software-defined radio. It can receive all these signals from the air, and you can tune it and everything. But they also have circuitry to decode the information you receive. So you receive a signal. There's noise, there's signal. You want to get the signal out, and you need to decode it, turn it into audio or data or whatever. And so these radios here have, a conventional radio, have circuitry that does that. A software-defined radio does not have that stuff, and so it is simpler. There's less going on. Instead of having this physical device here, which admittedly is half battery, you can have this little tiny device here. And so you can see there's a significant size difference. There's just less stuff in the software-defined radio than there is in a more conventional radio. So it's a regular radio, but with less stuff to decode. And like lots of these radios have circuitry to like limit noise reduction and that sort of stuff. Software-defined radio doesn't have any of that. It instead uses software to do the rest. And so it takes a raw signal from the antenna out the USB and then into your software to decode it. And I can sit here and talk about what this is for a long time, but it's actually easier to just show you. So we're going to show you. This is our first demo. We'll see if this works. So it's a little sluggish for the swapping of my video for whatever reason, but we can work with that. So this black screen is a piece of software called SDR Angel. The font is terribly small. You're not going to be able to read any of it, but don't feel bad. I can't read it on the screen either. It's actually kind of funny because, okay, so to be honest, radio, when you think of the typical amateur radio operator, someone who's in radio, you totally picture someone that looks like me, right? Middle-aged white guy, more into technology than people maybe. Probably can't see very well because his eyes are old, right? This user interface on this thing is so tiny. I'm like, come on. You know that the average age of a user of this software is 50, right? No, probably 60. But anyhow, let's go ahead and bring this up. So this is a little dialogue. I'm going to add my software-defined radio dongle, which I already have plugged in. I can read it well enough to know that it is the RTL SDR0. I'm going to hit OK. And then we got two little windows that pop up there in the top left corner. Top left one lets me pick a frequency. And I need to click a couple things here too. Turn the gain up. Maybe not that far. And I'm going to go to 080H because I know there's I think BBC's on there. And I'm going to hit play. And I'm going to stretch this way out. And let's see, let's turn the decimation down. There we go. So you can see a signal there slightly. It's not very, very bright, but you can see it. Let's see if I can get a better one. That looks better. You can see the line coming down there. It's not super easy to see. This antenna right here is hooked up to the software-defined radio, and it's picking up a signal. Let's see if we can find a better one. Anyone have a good station I should pick that you know locally? It's not something with music, because I don't want NDC to get a content violation.
How about Classic FM? Because that's all in like the public domain, isn't it now?
Yeah. I'm going to go with this one here because I can see it. And so there is a signal coming through there. It's a little weak, but we should be able to hear it. So let's go ahead and add a decoder, some sort of, so we're seeing this, it's putting it on the screen, but we actually want to listen to it. So I'm going to go to Broadcast FM Demodulator, hit apply.
What do you think? I feel like I need to watch breakfast. Your reward is promised.
Okay, well, it sounds like shit, but it works. So that's the idea. Now, I did this upstairs in the speaker room yesterday, and I got a perfectly strong signal, so I think it's because we're inside of a concrete box here. Or it could be this antenna likes to be on a metal base. So I think this is classical music, isn't it? I don't know what this is. I listen to heavy metal. But this is what a software-defined radio does. And there's lots of things out there that you can listen to, not just audio, not just, right now this is an FM radio with extra steps, right? It's not really that valuable, but there's a lot of broadcasts out there that are also broadcasting data, and you can decode that as well using the software. So I'm going to go ahead and let's see if we can pick one up, 162.00. We might be able to pick this up. And we might, if we see, I'm looking for little horizontal lines that show up on here. Watercraft on the Thames will send transponder signals out, and they'll show up on here, but I'm not seeing them. Oh, there's one. We'll go a little slower. That's probably too slow. There's one. See those little horizontal dashes? Those are transponder signals from boats on the Thames. And you can decode them and get information about those boats. So there's a lot of interesting stuff out there that you can pull down. So let's go ahead and stop this. Quit SDR Angel because I'm not going to use it again. And we'll go back to here. Hang on. There we go. So that was the first demo. There's lots of interesting data out there. If you're interested in playing with this yourself, the hardware is fairly inexpensive, easy to access. This is sort of the hardware path that I took. This is, the first 3 steps that I took. This ultimately led to me to becoming a ham radio operator and spending a lot more money than my wife knows about on radio. So if you're interested in playing with this, you can get the dongle and a little antenna kit there. That's where I started out. That's probably about $50 US. It's got the dongle, some basic antennas. You can stick it to your window, play around, see what signals you can find, right? This is where I started. But what I found is that I wanted to listen to all the shortwave radio broadcasts. And to be clear, these are all receive only. You cannot transmit with these. And so in the US, you can listen to anything as long as you don't share it with everyone else, unless it was intended for everyone. I don't know what the specific laws are for what you're allowed to listen to in here, so buyer beware. But this is where I started. But I wanted to listen to HF shortwave radio broadcasts. And so I got a better antenna. This software-defined radio dongle will do it, but the antennas, I was using homemade antennas. They weren't working very well. The way it works to do HF broadcasts, to do that shortwave radio, is a little bit of a hack. And so I bought this antenna here. It was about $50. It's a little loop antenna. It's about, 60 centimeters in diameter. I put it in my dining room window and hooked it up to my computer. And I was able to pick up Chinese radio broadcasts from Lhasa, Tibet in Columbus, Ohio. So literally the other side of the world. Very exciting. Now, they were sending a lot of power, but still, it had bounced off the ionosphere and made it all the way to the Great Lakes. Eventually, I upgraded to this. And this worked really well with the HF antenna that I had bought. So because of the way that this one here, where's my pointer? There. This guy here, the way it works, it's a little bit of a hack for the shortwave stuff, and it's just very noisy. And instead, you can buy an up converter, which will listen to those lower frequencies very well and convert them to a higher frequency that the software-defined radio can then to deal with. So you can up convert them and listen to more stuff. And when I did that, I started hearing all kinds of stuff. So this is the hardware if you want to play with it. If you're interested in software-defined radio, you want to get into the software piece. All the software is free. The hardware is pretty cheap. There are 4 main tools that I looked at that you could check out. There's SDR Sharp. Any guess what programming language that one's written in? Shockingly, that only runs on Windows. This is probably the most popular package out there. It has a lot of plugins, a lot of community support. It's a little fiddly. A lot of the stuff tends to be because it's all made by hobbyists and it's not commercial software. But SDR Sharp is a great place to start. If you are more interested in doing stuff on Linux, like you want something that's tight and can run on, say, a Raspberry Pi, GQRX runs fantastically on Linux. It's a good option there. It's basic, but it gets the job done, and it doesn't need a lot of resources. If you're a Mac user, the first one I found to work on my Mac was Cubic SDR. It kind of reminded me of GQRX, but worked on my Mac. That's about all I could say about it. And the one that I demoed earlier, which is the one I like to use, is SDR Angel. SDR Angel is very full-featured. A lot of the stuff you might want to encode or want to decode, you have to, with like SDR Sharp and the other ones, you have to create virtual sound cards and then pipe them into different software. So I'm going to set my software-defined radio. I'm going to take the output of SDR Sharp and send it to my virtual audio cable, and then another virtual audio cable is going to come into another piece of software that's listening on a sound on a port, or listening on a particular audio port. They can then decode the data there. SDR Angel does all of that inside of itself, so you don't have to do any of these plugins. So it's a very full-featured piece of software. Its learning curve is steep. But we're all developers here. I recommend SDR Angel. Go for the steep learning curve. Go big or go home, right? And I mentioned this earlier, but there is more than audio out there. There is data. I mean, you can listen to the ham radio operators talk to each other on these things, and that's fun. It's kind of like you're spying on them. But there's a lot of data out there, too. And some of these things aren't really strictly speaking data, but they're data formats that people use to communicate. Probably the most popular one that's still in use is Morse code. There are still a lot of amateur radio operators who communicate with Morse code. Strictly speaking, it's not a data format, in the same way that handwriting is not a data format. Morse code is keyed by a human, right? They use paddles like this. And that human will sometimes have a way of like, well, whenever they do their W, they kind of trail it off longer at the end than they should, or things like that. And so you can actually recognize people's handwriting, they call it their fist, on Morse code. So it's not strictly speaking machine decodable, but it is popular. And it's popular because you don't need a lot of data. You don't need a lot of bandwidth to send the data. And so with Morse code, a lot of operators who are skilled, if conditions are good and you're skilled and you've got a good antenna setup, you can use 1/4 watt of transmission power and reach around the world. Now that's skilled, weather's agreeing with you. But you can do very low power and get really far. 5 watts will get you anywhere. So Morse code's still out there. You can intercept this, listen to it. It sounds kind of cool. It sounds like the 50s. RTTY is still out there, and it's mostly used by hobbyists at this point. This is radio teletype. Used to be, you had these big physical machines, and you could type in them when they had paper. You type into them, and then it would send over radio, and then when you receive over radio, it would print what it received. This is a true data format in the sense that you're sending encoded text. So I type a letter, and then it gets sent to a particular pattern of radio signals. You can intercept these and decode these with software and listen to them. You'll mostly hear people doing contests where they're trying to see how many contacts they can make over a certain period of time. And so these are some old radio standards, data standards. Something a little bit newer that I've played with quite a bit is APRS. This is the Automatic Packet Reporting System. APRS is it's an extension of packet radio. And packet radio used a protocol called AX25, which is just amateur X25. Anyone here familiar with X25 as a networking protocol? Anyone old enough to remember that? That's probably the question, right? So X25 was turned into AX25 to do packet radio over the internet, so you could establish connections, and you could run an entire TCP/IP stack on top of it. Now, in practice, establishing those connections is brittle. It's at 1200 baud, so it's really slow, and it just wasn't used that often. The fun thing about this is that where instead of having a MAC address to identify your network card, you use your call sign, and that uniquely identifies you. But APRS was sort of the simplification of the AX25, where they got rid of the whole idea of trying to establish a connection, and instead you use this protocol to just send bursts of information out to announce things. And so you can, for example, assign that to, well, I got a slide talking about the things you can announce with it. So people will put it on their vehicles, and then when they're driving around, they will have their radio transmit their location, their latitude and longitude, and their call sign, and maybe a little message saying I'm driving down the highway in my big old pickup truck. And so then you can track that vehicle on a map. Like if you're receiving all those coordinates, you can track it. What's fun is that when you track them, you find out everyone's always speeding. You can send, people often send weather stations. So they'll take a little, those little like rooftop weather stations that people will put up? They'll transmit every 20 minutes. This is the temperature. This is the barometric pressure. This is how much rainfall I've seen. And so you can transmit weather information. And this is being transmitted, just shouted out every 20 minutes. Hey, I'm this station, and this is the weather right now. That's what it does. And if you've got a radio, you can receive these and listen to them and get the information from it. And individuals can just use their radios hooked to their computers and transmit these messages as well. So I could say, I am this call sign, I'm KE8VIY. I'm at this location, and I'm trying to reach, K8 Bob at, this, and hey, here's my message I'm sending you. Meet me at the square so that we can grab a beer. And so you can send messages out. And when these are broadcast, then, of course, they can be picked up by individuals with a radio, just listening to them. But more interestingly, with APRS, they can also be picked up by repeaters. And so the way this works is that part of the message is a path, or there's a counter in that message that says how many times to repeat it. So if I send a message out, I'd say, repeat this twice. And then a repeater picks it up and says, okay, I'm going to send it out again, and I'm going to take that number 2, make it a 1. And then the next one says, I picked this up, I'm going to repeat it one more time, and then it doesn't get repeated after that. And this allows you to get your packets of information, your broadcasts, over the horizon, because this is all line of sight. And so you can build little data networks this way. But the most interesting part of APRS is it's not only radio. There are internet gateways. And so I can send a message to someone who is on the other side of the world, and it will go into one of these repeaters which has a gateway on it, into the internet, come back out some other repeater on the other side of the world and send a message to them there. If the network knows they're there. So there's a whole cluster of servers that manage this. It's all running on AWS. And messages can come in, and message can go out. And you can build services that will respond to you that have names. And so there's a service called WXBot. So it's a weather bot. If you send a message from your radio to WXBot and give it a postal code or a city name, in the US we use zip codes, of course, it will respond back. It'll get picked up, go through one of these internet gateways. Software on the internet will look up the weather and send a message back to the internet, to the network, comes out an internet gateway that you sent it from, and then you'll pick up the weather forecast. And so there's these services. There used to be an SMS bot that would send messages over SMS to you, but it started getting spam and they had to shut it down. There is a WhatsApp bot, however, that you can actually WhatsApp someone through your radio, and the person can WhatsApp you back. And so if you're got your radio and you're hiking in the woods and there's no cell phone reception, but there's a radio repeater nearby that can pick you up, then you could get a message out. Mostly it's just fun. So APRS is really neat. It's a worldwide protocol, different frequencies in different parts of the world. Here it's 144.8 megahertz, which is in the 2-meter band. And since this is all on the internet, you can go view it. This is APRS FI, where you can go and view all the packets that are being broadcast by various devices across the world. This is a map of Columbus, Ohio, where I live. And I'm right there. That's where I live. You can see, like up there, there's a car that's got a little line on it, so they're driving around. So it'll do some pathing as well. So it's kind of fun to go look and see what everyone's doing. This is where you can see where people are speeding. So this is APRS. I could probably turn my radio on and try and pick up any APRS packet, but there's not really a lot of traffic in this part of London because it's all big monuments and not as many people, I guess. But APRS is really neat. It's a fun format to interact with. You can decode that data and just see what's happening out there. I mentioned AIS already. AIS is the automatic identification system for ships. They all have transponders and broadcast information about their heading and their location. So here's where I'm at, here's what direction I'm going, here's how fast I'm going. And it operating on these frequencies. And you can easily use SDR Angel to decode those signals and see various ships wherever they're at. In fact, this shipping data tends to be picked up by satellites. So there's satellites that are listening at these frequencies. And so if a ship's in the middle of the Pacific Ocean, that can pick that up, and then you can keep track of where that ship's at. If you've ever used Flight Radar 24 or FlightAware, you can see where all the airplanes are at. There's similar sites that do that for watercraft at vesselfinder.com and marinetraffic.com. Here, there you go. Here's a quick screenshot of one of these. This is of the northeastern United States and the upper Midwest. So it's the Great Lakes. And so you can see there's lots of boats on the Great Lakes. There's a lot of boats over here in the New York City area. But you can also see down there on the left, you see that line of marks? That's the Mississippi River. So you can kind of see the waterways on this. And this was a lot of fun. I was in Pensacola last December with my wife for our anniversary, and there were ships, and we had a little ocean view hotel room. It was beautiful. And we saw a ship out in the ocean, and I'm like, let's see which one that is. And I look it up, and you can find its name and everything, and it's great. There's all kinds of information on these ships out there. So I'm gonna skip the demo on this because I kind of showed you the signals already. But the star of the show is really ADSB. There's lots of other data formats out there. ADSB is the one we're gonna build a demo around. But I'm gonna talk about a couple others before I do. So there's interesting things that emit data. So one of the things that I've been able to pick up with my software-defined radio is my water and natural gas meters. So someone doesn't come and read my meter. They drive a truck past, and it just broadcasts my water meter reading every minute or so. And so I can intercept that and see it, along with all my neighbors' water meters and gas meters. I don't know who's who, but someone's using a lot of water. So that one's kind of fun. Another interesting one, this is probably the most random one that I think is just it's kind of absurd. So you know how in your car, it'll tell you have low tire pressure? You know how it does that? There's a little radio transmitter in there. There can't be wires because it's spinning, right? So there's a little radio transmitter in there. Well, you can pick up those radio transmissions and determine the tire pressure of all the people that are driving past your house. You just pick up, they go like, 50 feet maybe, or 100 feet. They don't go very far. But you can pick up these transponders, or these transmissions from the tire pressure sensors in vehicles, which is kind of, it's utterly useless, right? But it's just like, I'm looking at this information, and why do I need to know this? I don't know, but it's really neat. It tells you the pressure. It actually tells you the temperature as well, because that matters for your tire pressure. And so this is some of the fun data out there. Something fun that I thought you could do once would be you can intercept the garage door button push the signal as well. And I took my garage door opener, the little button apart, and there's like 10 jumpers in there, 10 dip switches, where you can sit there and set the code, which means there's 1,024 combinations, because it's a 10-bit number. And I'm like, do you know how fast I could go through 1,024 combinations with a piece of software and open my garage door, or any garage door? Pretty quick. And I thought, well, wouldn't it be funny once to do that at a very high power? Just open all the garage doors in your neighborhood. I think that would be fantastic. It'd be a great way to go to prison. But yeah, there's lots of fun stuff out there. But let's talk about the ADSB stuff. So that's the automatic dependent surveillance broadcast. These are words, so I can say them. I don't know exactly why they call them that. But the way ADSB works is that every aircraft has an antenna, and it broadcasts information about its location, its heading, its speed, its altitude. At 1,090 megahertz, it broadcasts that, and you get an aircraft ID. This is uniquely, every message has the aircraft ID. This is unique aircraft ID. This aircraft ID happens to belong to, any guess? No, Elon Musk. So I hope I don't get kicked off Twitter or X for doxing him here. But this is Musk's. It's out there on the internet, publicly available. So that's his aircraft ID. These aircraft IDs are just 3-bit numbers, or 3-byte numbers. This is a hexadecimal number. There is data hidden in it. So if the first digit is an A, that means it's an American aircraft. If it's C, it's Canadian. And then everyone else didn't get numbers that correspond to the names of their countries because North America did it first, I guess. I don't know. But everyone has a unique identifier. There's a call sign. This is what the aircraft identifies. If it's in the US, if it's a private aircraft, it usually tends to be an aviation call sign, so it'd be like N628TS. If it's some sort of commercial flight, it usually tends to be that flight number and the airline. So like it might be Delta Airlines flight 32, so it'd be DAL 32. If it's military, which I have seen a few times, US military is the only ones I've seen, they tend to have call signs that are whatever the pilot thought would be fun to put in. And so I was actually giving this talk in Poland one time, and I was rehearsing, making sure all my stuff worked in the hotel room, and I see Duke 55 come across. And I'm like, that's got to be a US military aircraft. And sure enough, it was, and I went out and looked at it on, I think it was the Open Sky Network, or it might have been Flight Radar 24, but it was out there, and it had just come from some airfield very near the Russian border for some reason. I'm not sure why. But so these call signs are a little more information about who's flying, what the aircraft is. You have your altitude. In this case, that's always in feet. That's just the standard. You've got its speed in knots. You have its heading in degrees. And it has a location with a latitude and longitude. Now, each broadcast that comes from the ADS-B transponder on the aircraft contains some of this information. They all contain the ID. They all have to contain the ID. And they're saying, I'm this aircraft, and this is my call sign. I'm this aircraft, and this is my altitude. I'm this aircraft, and this is my location. And there's other information other than this as well. And it transmits all this. And you can use a software-defined radio to receive this. And the easiest way to do this is to use a tool called Dump 1090. So this is a screenshot of Dump 1090 that I did at my house about a year ago when I put together this talk. And you can see that DABJet 55, that's a military aircraft. If you see that UAL 296, that's United Airlines Flight 296. You see like the N266TD, that's probably some hobbyist flyer because you can see that they are at an altitude of 5,000 feet, so they're not super high up, whereas like the United Airlines is at 31,000 feet. And so this is the data that you get. And we're gonna try and pick up some aircraft with this. Through great coincidence, this is one of those things that I discovered as I was building this talk. The Dump 1090 software was written by Salvatore, who's the guy who created Redis. He did it on a weekend, or like over a holiday with his family around Christmas time, because I guess this is how you relate to your family around Christmas time. And so I'm gonna go ahead and get to our next demo where we're gonna try and run this. So how am I doing on time? I think I've got plenty of time. So let's go ahead and, I know you don't see anything just yet, but you will, I hope. There we go. I'm switching out the antennas here. The antenna that's here is optimized for picking up the stuff we were looking at earlier. It's for 2 meter and 70 centimeter. I have an antenna down here, which we'll see in just a moment, which is optimized for picking up aircraft transponders. So here is that antenna. As the wizard holds up his magic wand. So here we go. I'm gonna lay this down inside of here for now. And I'm gonna go ahead and see about getting Dump 1090 going. So I'm in a folder here with Dump 1090. I should be able to do /dump 1090 -- net. The -- net will open up some TCP ports where it will expose the data that it's receiving so you can interact, so you can connect to it from software, which is what we're gonna do eventually. -- interactive makes a nice little dashboard of all the aircraft. We're gonna hit enter. It hasn't crashed. That means my software-defined radio is working. Haven't picked anything up yet. Let's see if that works. There we go. We picked up a couple aircraft. There's DLH 3NP, British Airways Flight 29G. Those are probably both coming in. Headings 270, so that's due west. They're lined up to go to Heathrow. UAE 70M. So we're picking up a couple aircraft, not a ton, but a couple. If I was out there in the lobby with the big windows, we'd pick up a lot more. I did this in the speaker room yesterday, and I picked up stuff from in the channel. But you can see the number of messages we're getting there on the right. Some of these are sending a lot of messages. Like if we look at flight DLH 3NP, you can see those numbers are ticking by pretty quick. Others aren't giving us quite as many messages. So picking up aircraft, good. So that's cool. But let me show you what this exposes, right? So if I do a netcat to localhost, and I do port 30,002, these are the hex encoded messages that we are receiving. So this is the raw data being sent from the aircraft. And this is coming from the sky. It's literally coming from this antenna. And one way I can show it is that the aircraft on the antenna are sticking out of the belly downwards. And so they transmit like this, so they're polarized. The signal's polarized in a certain way. If I lay this down, make it horizontal, the messages stop coming in. If I hold it up, they start coming in again. Now, if the signal's really strong, it'll pick it up anyhow. But you can see it's actually like the data's coming from the antenna, which is kind of cool. And so do you think you could parse this with some code? Absolutely, right? It's just hex. Well, it's not even that hard. Because if we look at port 30,003, it's CSV. But it's even easier than that, because this CSV is actually in a standard format that's used. I don't know what the standard's for, but it's a standard called SBS1. And this standard format has a node library. And so you can literally say, go to this server, go to this port, and then it will just emit an event whenever it receives an event, and it will give you a JSON object. And so connecting to this from node is piece of cake. So let's go ahead and kill that for now. And we'll let that run in the background here. And I'll show you what I've built using the fact that I can do this. So I'm going to set this down again. There we go. Let's go back to presenting here. There we go. So real data from the skies. It's cool, right? So what I've done is I've built a thing using Redis and this software-defined radio to track these aircraft. So I'm going to take those transponder signals. I'm going to put them into Redis on an event stream. I'm going to then consume that event stream to populate various things in Redis, and ultimately we're going to put these on a map. And so we're going to make a map of all the aircraft around us using nothing but data from this antenna. Sound cool? I think it's cool. It's weird when you get it going because it's oddly compelling. I remember I showed this to my mom, and she's like, her initial reaction is this legal? Yes, it is. At least it is in the US. I hope I'm not breaking the law here. If I get arrested at the end of this talk, it'll be the most memorable talk ever. It was amazing. He did all this stuff with the radio, and then he got arrested at the end. So I'm going to shove all this into Redis, put it on a map. The version of Redis I'm going to use is a version called Redis Stack. So Redis Stack is a version of Redis that has some extra capabilities than open source Redis. It's got the ability to store JSON documents as JSON as trees. And you can get Redis Stack either as a Docker image or you can use the cloud offering. And the license is very, very permissive. We basically say, don't compete with us. That's really what the license says. Not a lawyer, read the license, but it says don't. It's basically, the idea is if you're an insurance company and you want to use Redis Stack and just run it yourself and not pay us a dime, you're permitted to do that. If you want to take Redis Stack and say, look at this new JSON data store that I made. No, you can't do that. But it has JSON capability to store JSON documents. It has the ability to search JSON and hashes so you can find the particular values you're looking for. It has the ability, has some probabilistic data structures, which is another talk that I've given in the past. If you're curious about that, I'd be happy to talk about it later. But they're quite fascinating. And it's got a time series database in it as well. So if you want to do like temperature over time or stock prices or whatever. Actually, another Elon Musk connection, one of my coworkers was live streaming doing stuff with time series when Elon announced that he was going to buy Twitter. And he was consuming the NASDAQ feed in real time and shoving it into Redis time series. And all of a sudden, in the middle of the stream, the volume just shot through the roof. And he's like, what's going on? And people in chat are like, oh, yeah, he just made the announcement. So it was kind of entertaining. But that's all in there as well. We're going to be using JSON and search. I'm not going to talk a ton about it, but I will show you it in action. So I'm going to talk about what I've built. So I've got what I could call a microservice architecture, but I'm probably abusing it by making them too small. But I've got a series of services that I call radio ingesters. And the idea here is this is a bit of code that runs that connects to a particular software-defined radio and then populates an event stream in Redis. The idea here is that I could have one here, and I could have a coworker in Seattle with one. I could have a coworker in Bangalore with one. And then we could get multiple bits of data coming in. You okay on audio? I heard weirdness in the background. So, let's just make sure that's off. It is. So we're going to take all those events that you saw streaming along as JSON objects. We're going to shove them into an event stream on Redis. I have a service that I call the radio consumer that is going to consume that event stream and then populate a JSON object with the current status of that aircraft. So If I get an aircraft ID and I get their altitude, then I'm going to update their altitude. If I get then their altitude again, I'll overwrite it. So this is the current status of that aircraft. And that's hooked up to Redis Search. And there's an API where you can say, give me all the aircraft that are heading north, or give me all the aircraft below 20,000 feet, that sort of thing. I'm also going to consume this stream and send it down a WebSocket using a flight events API. So you can just subscribe to the socket, and you'll get a WebSocket event with the data in the stream that has the aircraft ID, its location, whatever is in that message. And we can put these together with a little UI that's deployed on Nginx and an API gateway to front it all so that they can all see each other. And this is the thing that I've built. Now, we're not going to go into detail on every single thing in here because it would take more time than I have. But we'll touch a couple points. We'll talk about how the ingester works. We'll talk a little bit how the consumer works so that you can see how the streaming portion of this works. So first things first, a little bit of JavaScript code. This is JavaScript code. I'm sorry, that's just my go-to. You could do this very easily in C# or whatever language you prefer. I do it in JavaScript because I hate myself. So two libraries that I've got to bring in JavaScript. I'm using SBS1. This is the library that knows how to talk that protocol. You just give it the port, the host, and it creates objects. And I bring in Redis. To connect to SBS1, you just call create client and give it a host and a port. And it gives you a connection or a client. Easy peasy. To connect to Redis, you have to create a Redis client and give it a host and a port and a password. And then you have to make sure you catch all your errors, and then you call connect on that client. And then you're connected to Redis. So this is how we connect to all the things we're going to interact with. Then we will wait for messages from SBS1. And so we'll say SBS1 client.onMessage, and then we'll get a message object, and then we'll process it. The processing is not particularly brilliant. This is just a simple flat JavaScript object. It's got the aircraft ID, the altitude, whatever. They're all strings, and so there's some massaging where it's like, oh, this needs to be turned into a number and that kind of stuff. So we'll process that message and turn this into a nice, tidy event object. And because not everything's there, I've got a bunch of ifs in there. So this isn't particularly interesting code. It's just taking that data and turning it into something useful that we can deal with. So once we have this event, then we can add it in our code to our event stream. Now, who here has worked with event streams before, like Kafka? A few of you? Anyone not worked with event streams and have no idea what an event stream is? A couple of you. So I'll go into like the super basics of what an event stream is. It's a big topic. I don't want to go through all of it. We don't have time, but we'll do a quick idea of it. And this is in the context of how they work in Redis. An event stream can be thought of as a log file or a history of events, a chronological sequence. And so you've got an event happened, and then another event happened, and another event happened. And they're just events. They're things that happen at a point in time. And they have with them data that is associated. In the case of Redis, this payload is a bunch of key value pairs. So got a key, value, they're both strings. So we can take that event object that I created in my code, and then it becomes the data associated with this event in the stream. And in Redis, this is all in one key. And so it's just a stack of events in a key. Each event has an ID. That ID uniquely identifies it. It's in order of that ID. In the case of Redis, that ID is made up of two parts. The first part is the timestamp in milliseconds that the message was received. You can do this manually if you want. I don't recommend it. And a sequence number in case you get more than one message a millisecond, which you will probably see when we start running this. And then as these events come in, they just start stacking up. And so we get a history of all the events that come in, from whenever it started to whenever you're done. And it's just a slice of events over a piece of time. You can trim these down, you can let them grow forever, it just depends on what you need to do. So this is how an event stream data structure works in Redis. This is super high level. If you want to get into event streams, there's better talks than what I'm going to give here on that, but I want to show them so that you know them well enough so you can see what we're doing here. In our case, that object is our aircraft data and the timestamp. To use streams from Redis, you use the xadd command. you give it the key name, you give it an ID. Now, I put star in there, and that means Redis, make up your own ID. Use the timestamp. It's way easier. You can do it manually if you want. And then key value, key value, key value, key value. And you can enter this command in Redis, and it'll execute it. You can also do this from code, and I'll show you the code in just a moment. When you then want to read a stream, use the xread command. You give it the streams keyword, and then all the streams that you want to read from, and all the IDs where you want to start. So this is a terrible command to run, because this says, read this stream from the beginning of time until the end of time. So if you have 10 items, you're just going to get 10 items back. If you have 1 million items, you're going to get 1 million items back. And if you get 1 million items back and Redis is busy handing them to you doing that, it's not busy doing anything else, because Redis is single-threaded behind the scenes. So, but when you do read, it will give you all the things that are there, and it gives you then all the information associated with it, including the ID. Here we're going to add another thing, and you see the timestamp changes. And here's another way, a better way to read. Here I'm saying read. I'm giving it a count and say, don't give me more than 10 things. Here's my streams. Here's my ID to start with. You'll notice what I've done here is that, where are we at here? There we go. This ID right here is the one I pass in down here. So basically, I've read the stream, it's given me some, and I get an ID back of the last thing that it returned me, and I can pass that in for the next time, and it will give me everything after that ID. Not on it, but after it. That way you can just read it 1 by 1 or 10 by 10 and tear your way through the stream in chunks. The code to do this is pretty much a mirror of that. So we were calling xadd. There's a key name, the star, the event, which is the JavaScript object, and that's equivalent to calling this. So that's what the radio ingester is doing, is it's creating that event object and then calling that code behind the scenes. To read these events, we're calling read in a different way. So here, instead of calling read and just giving it a stream and give me the next 10 items, we're saying read block 5,000. That means wait up to 5,000 milliseconds, and we're passing in a $sign for our event ID. That means start at the end. So we'll go to the end, start at the end, wait 5 seconds for something to show up. If nothing shows up, we'll come back. And so if we do that and then we add something, then we'll get a response back with that ID of what we read. And then what we can do is we can then take that ID and call the same blocking read and read the next one. And that lets us pick up at the, it's like tailing the log file. So we can read all the new things that come in. And this is what we're doing in this code here. You could build something that would read this event stream from the beginning of time to the end of time and replay all the aircraft data on a map if you wanted as well. We're not doing that here, but that's something you could do with this data structure. So here's the JavaScript code that corresponds to that. I'm going to skip over it because it does pretty much what you'd expect it to do. We're just setting our current ID to $, and then when we get things, we don't get anything, we continue. Otherwise, we process the event and update the current ID to whatever we got off the last message. And then here we process that event, pulling it back off of there. So, and I'm not going to talk about this WebSocket code because I don't want to. And it's boilerplate WebSocket code. You can find this anywhere. And it's in the GitHub repo if you want to play with it. But basically, I'm just shoving that object I get back that I recreate down the socket. So let's see this working. I think this is the fun part, right? This is why we're here. So let's go ahead and we got 6 minutes left. I don't want to keep you between you and your GNT too long. Let's go ahead and we're still picking up a few aircraft. We don't need this one here, so I'm going to exit out of that. So we still picked up 3 aircraft, even though we're horizontal with the antenna. So I've got the radio ingester here, and so if I do docker compose up, this will launch the radio ingester. It will start reading the transponder signals and start shoving them into an event stream in Redis. So we're going to go back here and see if we can pick up a few more aircraft. There we go. That's better. We're not getting a ton of them, but we'll get enough. And I'm going to go into this tool here. This is called Redis Insight. It's a GUI that lets you browse your Redis databases. It's great. You can just Google. It's on the App Store, and it's on the Windows Store, and you can also download it from our website. So I am going to look at just streams. I have another set of data in here that's around Bigfoot. So, but let's not look at the Bigfoot sightings. Let's look at the radio events. So here are the events coming in. So here is a particular aircraft, and its altitude is 3,675. Its latitude and longitude's there. If I refresh this, we should get new data coming in as I refresh it. So events are streaming in from the antenna to this event stream. So then I can write code to look at this event stream. Let's go ahead and I have written code to do that. Let's go ahead and get the rest of this thing running. Docker compose up. So now I've got that radio consumer creating JSON documents. I've got the events shoving WebSocket down a WebSocket. If I connect to it, I've got the GUI. This is everything else. And if I go into here now and go back to my browser and instead look at JSON documents, you can see there's aircraft here with information on JSON documents with the aircraft information. If I click on one, we can see that this is coming from Radio London, which is what I've named my dongle here. It's at 2,950 feet. It's SHT 15E, whatever that is. All right. So we are turning aircraft from that event stream into JSON documents. Pretty cool. But this is not the exciting part. We're going to do the map here. So if I hit the map here and hit Command plus a little bit, and I'm going to go ahead and Command Shift R. Okay, and if I zoom in here, you see there is an aircraft it's found. It just got its heading. It's down near Brixton. See, it's moving. This is you can see the call sign is Echo India November 38 Yankee. I don't know what that means, but that's their call sign.
Aer Lingus.
Oh, it's Aer Lingus. And if I click on it, on here, it'll take you to FlightAware. And it's coming into Heathrow. And are we picking up any more? We're not actually picking up a ton of aircraft now. How disappointing. I'm not getting a ton of messages. Oh, there we go. I just had to hold it higher. Are we getting... This is always the risk of this. So I've got a bunch of aircraft, but I don't have any latitude or long. There, I got a Latin long for TAP. And there's that one. So we picked up 2 aircraft. If we zoom in here, you can watch them move as messages come in. Yeah, see? They move as the messages come in because I just, each icon on this map has the aircraft ID with it. And when I get a new data, I just change its position on the map and then it moves it. Same thing for the heading where it will change. I tried to get the icons to rotate so the heading would be perfect, and that was actually too hard with the mapping software. So I have 16 images, and it gets you close enough. There's another one coming up here. And so, yeah, we're starting to see aircraft coming in here. So, and not getting anything super far away, but we are getting aircraft that's sort of in our immediate vicinity. I think if we were out there at the window, I would be picking up stuff over the channel. But yeah, we're getting real aircraft. And I built a little API here, so if I want to get all the aircraft that are, say, heading west, this is probably going to be all of them, then here's all the aircraft that have a heading of west. It's got some older ones from when we were running earlier, too. If I want to get everything that's heading east, you can see I've got one heading east. And so I've just got a little query there that does that. I built a little express service that returns JSON. It's nothing particularly brilliant. And I can get things like any aircraft above 10,000 feet or below 10,000 feet, et cetera. So I've got this little API that's using Redis search behind the scenes to do that. And yeah, that's my demo. I think that's most of my talk, but let's go ahead and set this down. We'll wrap up the talk. We got 1 minute to spare. The band wants to get set up. Screw those guys.
All our equipment is backstage in room 1 because they changed the schedule and John's still implementing SSH from scratch. So you've got as much time as you need.
Okay, so the only limitation here is beer, right? So this question slide, happy to take any questions. Or are there any questions? Just shout them out and I'll repeat them. And it's okay if you don't have any questions. You don't have to have questions. Everyone's like, we got a minute left. I want a beer. So a quick show of resources here. This is links to all the stuff that I've talked about here. There's Redis Stack. Here's the SDR software. Here are the AIS tracker sites. Here is the ADSB trackers. And don't worry about getting a picture of this. I'll do you one better because, and there's dump 1090, because I have a QR code at the end. So this links to all the stuff. This is stuff Redis would like you to know about. We got a Discord server at discord.gg/Redis. I'm the primary admin there, so if you have any questions, you can drop them in there, and I can ignore them until someone else answers them. We got free classes at university.redis.com, and if you want to use a cloud instance of Redis to play around with this, you can go to redis.com/tryfree. Here's a QR code that takes you to the GitHub repo that has the code, the slides, and everything you would want or need or care to know. You can trust this QR code. It will never give you up, nor will it let you down. So, and that is what I've got. So thank you all very much, and have a wonderful rest of your evening.